So I'll start this video going just back to that slide we did in class. So here's a scale, and in the scale you see there are 2 apples on the left side, 2 apples on the right side, 3 books here, and a puppy over here. Now, if you can tell by the scale, and you can tell the scale is balanced. The left side weighs as much as the right side. So the question here was, the dog weighs 6 pounds. How much does each book weigh? Well, one of the things we can logically conclude is that they are balanced. Okay, if they're balanced, and these apples, assuming that these apples are exactly the same, okay, let's see what we can do. We can determine that this apple and this apple weighs the same. This apple and this apple weighs the same, right? Therefore, leaving this book to weigh, these 3 books to weigh as much as this puppy. So one thing we can do is throw the apples out. Because if I throw these 2 apples out, what's going to happen? It's going to tilt this way, right? So in order to keep it balanced, I want to throw these 2 apples out as well. Now I have 3 books and the puppy. I know how much this puppy weighs. I know he weighs 6 pounds. So, and this also means the puppy weighs 6 pounds, right? Puppy weighs, why the puppy wait? Puppy weighs 6 pounds. This also must be 6 pounds because the scale is balanced. So now it's just a matter of dividing 6 divided by 3, which means each book weighs 2 pounds, 2 pounds, 2 pounds. Okay, so remember I told you I want you to think of these apples that we just threw off the scale as your constants. Okay, constants are, let me write a little expression here. So 3x plus 4. This is a constant, this is a coefficient, this is a variable. Okay, so we basically just threw constants out. So I want you to think of when you're dealing with these equations on this on the assignment, that sometimes you can throw these constants out so you can figure out the variable, the value of the variable. Okay, so let's see where that takes us. It takes us to that homework sheet, which I don't see anywhere. Here it is. Okay, so a lot of these we already did in class. So here is an equation, x minus 2 equals 15 minus 2. So here's what I want you to do. I want you to look at the left side of the equal sign and the right side of the equal sign. See if you found something similar. And there's a minus 2 here, and there's a minus 2 here. Because they're exactly the same, I'm going to remove them from my equation. So if I remove them, I have this left over on this side, and I have this left over on that side. Okay, so in this case, I get that x equals 15. And there's something, hang on a second. Okay, sorry about that. And then if x equals 15, I can go back to my equation. Okay, and it was x minus 2 equals 15 minus 2. Let's see if it's true. Okay, this says that x equals 15. So here I'm going to substitute 15 minus 2 equals 15 minus 2. And you can tell already that they're both the same. 15 minus 2 here is 13. And 15 minus 2 is 13. So my equation is true when x equals 15. B. Is there anything that you see that's the same? Yes, I do. A 10 here, a plus 10, I'm sorry, and a 10. This is also plus 10. These 2 are going to be crossed out, and I'm going to be left with 6x equals 60. So I'm trying to find, so my equation now says 6 times a number I don't know equals 60. How do I find that number? Well, I can set up fact families. This is a multiplication. So with multiplication, I can use division to find my answer. So 60 divided by 6 is 10, and there's my missing number. And from that, I can build up the other families. 60 divided by 10 equals 6. So now I can use 6 times 10 equals 60, or 10 times 6 equals 60. So which of these sentences here actually look like this one? Would be this one. So I know that the variable, the letter x, it can be replaced by 10. 6 times 10 equals 60, and see if it's true. 6 times 10 is 60, which equals 60 on that side. I'm not going to do all the questions, but I want to do a few that, do this one. 3m plus 8 equals 35. Now notice that there's nothing that they share on the left side and the right side, so this one's a little tricky. What I'm going to do is 3m plus 8, I'm going to write that, and then 35, instead of 35, I'm going to break 35 into two, the sum of two numbers, one of them being 8, plus, if one of them is 8, well, 35 minus 8 is 27. So another way of saying 35 is writing number 8 plus 27. Okay, I do that because now, look, I have an 8 on the left side, and I have an 8 on the right side. I can circle these two. Okay, they're exactly the same. I'm going to cross them out of my equation, and I'm left here with 3m, and here I'm left with 27. So this says 3 times a number represented by the letter m equals 27. So what is that number? Well, again, because it's multiplication, I can use division to find my mystery number, and 27 divided by 3 equals 9. So there is my mystery number, which is 9, and because of that, I can now write my other fact, which is 3 times 9 equals 27. Okay, so over here, 3 times 9 equals 27, and you'll see that 27 is equal to 27 on the other side. Let's see. I'm not doing E and G. I'll do G. So 14 is the same as the 14 on this side, so that's going to cross out. I'm going to be left with minus G and minus G on the other side. Notice that my expression on the left and my expression on the right is exactly identical. Let's try and pretend, let's pick G equals 5. G equals 5, I'm going to substitute. I'm going to get minus 5 over here. And minus 5 over here. So G5 works. Let's pick G equals 10. If G equals 10, let me just erase this. I'll get minus 10 equals minus 10. So hopefully you pick up that whatever I put for G won't matter. It will always be the same as the other G on the other side because I'm substituting the same number on both sides. So in this case, G is an infinite number of solutions. It can be any number in the world. Okay, E is okay, it's similar, so I'm not going to do that one. And then F I'll do. So F is a little bit different. Okay, still the same idea. So 23 plus 25 is 5x plus 24. Oops, so we got a 24 here, and on this side I have a 23 and 25, but I can change these two numbers. So why don't I do this? 23 plus 25 is 48, so I'm going to add those two. Okay, and that doesn't help me, but now I can go ahead and break them again. And 48 is, I can rewrite 48 as 24 plus 24 equals 5x plus 24. Now I have same thing on both sides, so I got plus 24 here and plus 24. I'm going to cross that out from my equation. I'm going to remove them, just like I removed those apples in the beginning. And what I have left over on my scale is that 24 equals 5 times a number. So 5 times this mystery number equals 24, and it can be a decimal. So because again it's multiplication, we're going to think division or use division to help us out. 5 goes in 24 4 times, 20. Add a decimal, a 0, 4, bring the 0 down. 5 goes to 48 times, so 4.8. So 24 equals 5 times 4.8. 24 equals, and 5 times 4.8 is equal to 24. So there, we just found our answer. The value of x that makes this equation true, x in this case, has to be 4.8. No other value will satisfy that. Okay. Let's see, there's a bit more, I believe, but I'm not going to do them all. So here's the same thing. Here's the same thing. That's simple enough. Let me do B over here. So I don't like the way it's written there, so I'm going to rewrite that as this. Half of x minus 3 equals 20 minus 3. So you see the minus 3 here, and this minus 3, okay? Remember to always take the sign too. That goes out. So I'm left with half of x equals 20. So half of a number equals 20. So what number can I divide by 2 to get 20? So this one is easy enough. Half of 40 equals 20. Okay, so I'll put this over 1. On the top, I get 40. 1 times 1 is 40. On the bottom, I get 2 times 1 is 2. Equals 20 on the other side. And 40 over 2 is indeed 20, which makes this equation true. I'll do G. So over here we have 92. Oops. What did I do? What did I do? What did I do? What did I do? No. Here we go. I have 92. Plus, again, I don't like the way that they wrote it like this. 3/4 p equals 1/4 of a p plus 92 plus 1/2 of a p. So in this case, nothing I can do on this side, and you see the 92s are. I have a 92 here and a 90, so I can circle those two. But before I do that, I'm going to do something else. I'm going to do 9. I'll copy this, and I have a p and a p here, so I'm going to combine these two and make it into one single. So 1/4 of p and 1/2 of p. Think of 1/4 as this, 1/2 as this. So if I add that plus this plus this, I should get 3/4. So writing it again, 3/4 p plus 92. I combine the like terms. Okay. Now I know that these 92 and this 92 is the same. Cross out, and I'm left with 3/4 p on this side and 3/4 p on that side. So if you're left with something with an expression that on the left matches the expression on the right exactly the same, we should know by now that p could be any number, okay, and would satisfy this condition. So if I replace p by 1, 3/4 times 1 is 3/4, and on this side if I replace by 1 again, 3/4 times 1 is 3/4, be equal. Doesn't matter what you replace p with, it would give you the same, it would satisfy this equation, okay? Any number, infinite number of solutions, okay? I'll do one with distributed property. Okay, so let's pick this one. So I can't do anything in this format. I need to use a distributed property to remove the parentheses. So 4 times k, then 4 times 8. 4 times k is 4k plus 4 times 8 is 32 equals 24 is 32. Notice I have something in common. Plus 32 plus 32. They're both going to go out. I'm left with 4k equals 24. And that says 4 times a number that I don't know of, represented by k equals 24. So I'm going to, the opposite of multiplication of division, so again I'm going to use that to help me find my value for k. 24 divided by 4 is 6, so that's my mystery number. And when I have all these three numbers, I can now write this relationship. 4 times 6 is 24. So I'm using this to help me. So I know that k is now 6. 4 times 6 equals 24. And this 24 equals this 24. Okay? And that's that.